Welcome to Miss Taylor's Notes. Today we're going to talk about correlation and causation and association. So what we're going to get into for the next couple of lessons is we're going to be talking about scatter plots or data. And so scatter plots or data are graphs that use points to display relationships between two sets of numerical data and can be useful for observing trends, patterns, or association. A-T-I-O-N. Between two variables. So, if the overall data resembles a line, the association, thank you, Belle, the association is described as linear. So, we're going to be looking at only linear association right now. So again, when we think about association, we need to think about slope. Is it positive and going uphill, or is it negative and going downhill? Or is there no line at all, so there is no association? So again, here, if we look at the data, if we were to draw a line as close as we could in the middle, this would be a positive, again, think slope. And as the value of x increases, the value of y increases. So if it's negative, which means if we drew a line, it would be going down as it goes left to right. So again, negative slope. As the value of x increases, the value of y decreases. And then again, if we couldn't draw a line, if we could draw a line in any way and it work out, then it's going to have no association or no effect on the other. So outside of just looking at association, we have to look for something called causation. So causation means cause and effect. And what we mean by cause and effect is that the two variables have a relationship with one another and can change the other one and have that, again, cause and effect relationship. So causation exists between two variables when the change in one variable causes the change in the other. So if we look at these scatter plots up here, so if we look at hours studied, so as somebody studies more, their grade gets higher. That to me as a teacher, I know is cause and effect. The more you study, the better grades you get more often than not. Occasionally there's a fluke, but most often, yes. So we know that this right here is an example of causation. So as people sell fewer snow cones, sweaters go down. Well, fewer snow cones doesn't mean more sweaters. It just happens to be it as fewer snow cones are sold, it gets getting cooler. And if it's cooler, you're more likely to need a sweater. So these do not have causation. They just happen to be dealing with the cold. Now, if this was temperature, then yes, it would be cause snow cone sales go down as the temperature goes down, or the temperature causes snow cone sales to go down. Person's age and pairs of socks owned. So your age really has nothing to do with socks. Oftentimes the youngest people have the most socks because baby socks are just the cutest in the world and people buy babies lots of socks. So again, that one doesn't work either. So now we're going to have to look at the difference between association and causation. So as the number of cars in a restaurant parking lot increases, so we have cars in lot here, the number of seats in a restaurant there. So let's think of our graph. So as the cars in a parking lot increase, the number of seats decreases. So if there's fewer cars, it's there. Okay, so that would be a negative association because as the cars increase, the seats also decrease. And you would think that the more cars that show up in a parking lot for a restaurant means there are more people in there. So yes, this would be causation, because if more people are parked outside of the restaurant, more people are in the restaurant, so there are fewer seats available. So now let's think about this one. As your height increases, the price of gas. So they're both increasing, which is going to make it positive association. But height has nothing to do with gas prices. It's not just because you get taller, gas prices get more expensive. The thing that gas prices is based on stock market and lots of other things. So no, this is not causation. They do not cause one or the other. So the next thing that we're going to start talking about is types of data and types of scatter plots. So if we look at A and B right here, they both have a positive association. But if we were to draw that straight line in the middle, graph A's dots are a lot further away from the line than B's dots. So they both have positive association. And so what we want you to do is we want you to predict which one would be stronger. And again, I kind of explained it. A's dots are further away, which means it's not going to be as strong, whereas B's are all really close together, so it's going to be stronger. So when we look at association, association can also be called correlation. The more points are spread out or scattered, the weaker our linear correlation is, whereas the closer they are together, the stronger the linear correlation. We can actually calculate the correlation coefficient using technology. Our correlation coefficient is known as the letter R, and our value is going to be between -1 and 1. So we're going to imagine that this point right here is -1/2 or -0.5. And so if it's between 0.5 and 1, it's going to be strong negative. If it's between -0.5 and 0, it's going to be weak negative. Again, here we're going to pretend that this is 0.5 or 1/2. And so weak is between 0 and 0.5, and it's going to be positive. And then we have strong positive if it's greater than 0.5. And so again, we can use technology to do this, but we can also kind of use the eye test as well. So I'm gonna ask you to match up these 4 numbers based on these graphs here, and I want you to check the completed class notes. All right, so now we're gonna show how technology using our graphing calculator, I'm gonna use Desmos, to find our correlation coefficient and to see what it will tell us. So when we're given a table like this, our X is always on top and our Y is always on bottom. So I'm going to pull up my Desmos calculator, and I want you to do the same as you're watching this video. So to find our correlation coefficient, we need to hit the plus button and we need to create a table. And here's the thing that's going to take us a while. We need to type in this table. So my X value is 10, my Y value is 1. So I've got check, check, 2, 4, 8, 1, 6, 2, 1, 6, 3, 3, 11, 0, and then 7, 1. Okay, so I've got all my data in my table. What's really cool about Desmos is I can hit this plus sign right here, and it's going to zoom in on my data for me. So underneath the table, I'm going to click on the box below. We're going to hit Y1 because we need to use the values in the table. In the table on Desmos, we call it X1 and Y1. So Y1, and then we're going to find our squiggle. Our squiggle on your keyboard is if you hit Shift and the button left of the number 1 will get you the squiggle. And we're going to go MX1 plus B. So we've taken our Y equals MX plus B. We've put a 1 next to the Y and the X. And instead of the equal sign, we've put the squiggle, or what means approximate. And so here, Desmos is going to give us a lot of data, but we said our correlation coefficient is R, and so our R value is negative 0.93. We're always going to round to the hundredth, which means we're going to look at the second number after the decimal, and the number after it is either going to be higher, or 5 or higher, or 5 or greater, which is going to make it higher, or 4 and lower, which means we're going to stay. So negative 0.93. So this is going to be a strong negative correlation. And so now I want you to do number 2 on your own. If you need to pull up the completed class notes to remind you of the steps, you're more than welcome to. And then I want you to answer number 3 and check with your completed class notes.